and our first presentation will be Sencha. And with us, we have Stuart Ashworth that would help us with that.
Great. Well, thank you very much, Finn. Welcome, everybody. Thanks a lot for coming along to the first session. I know maybe there'll be a few yawns and things, but don't worry, we'll get started and hopefully we'll have a good day of talks. So I'm going to talk today about building web applications with Sencha's Ext JS framework. So if you want to have a look at the slides, there's a link there. Perhaps one of the guys could put it up in the chat, but they'll be sent around afterwards, as Finn just said. So a little bit about me before we start. My name's Stuart. I've been building applications on the web for 15 plus years, working with Sencha for 10 of those years. So I've worked with a lot of large-scale web applications built with XJS, and both sort of targeting desktop and on mobile too. I've written a few books on XJS and how to use the framework, and there's a new one coming soon. If you are interested, you can check out the web address there. And if there's any questions or you want to chat with me about anything that you've learned or have some questions about it, then you can drop me an email with that address there, and I'll get back to you and we can talk about whatever questions you have. So quick rundown of the format. I'm just going to do a quick presentation about what XJS is and how it fits in with the current landscape and the sort of pros and cons of it and that sort of thing. And then we're going to do a few code demos just to demo how we can build things really quickly with the framework, and a few of the neat features and stuff that it has. And then we should have some time at the end for questions that you have, but feel free to put them in the chat as we go, and we can either cover them as we talk, or we can round them up at the end. So let's get started. So just start by giving a quick introduction to XJS and what it actually is and what it offers us. So this is how Sencha describes XJS. It sums up its strengths very well. So it's a JavaScript framework for building data-intensive enterprise web applications. So let's break that down a little bit. So you notice I've underlined the word framework. So XJS is a complete solution, and that's where it differs slightly from the other options that you might compare it to. So things like your Reacts, your Views, your Angulars, these are all libraries which only really cover a subset of XJS's functionality. And the big difference is that you have to pair those libraries with a whole host of other libraries to get the full solution. This is a big part of why XJS is good, because it has it all there ready for you. It also says it focuses on data-intensive applications. So its real strengths lie in handling and displaying lots of data. So with fast grids of tabular data, we've got complex forms and data entry workflows and complicated data models. So these are all things that XJS is really geared up for. And it also mentions enterprises because they're the companies that are most commonly building applications like this. And we'll talk about the key reasons why you might choose XJS in a minute. So a few of the headline features of the framework. It comes with two UI toolkits, the classic and the modern, and they help you target both touch platforms and desktop platforms with a bit more of an appropriate experience for each. There's also support for model view controller and model view model architecture, so that helps us structure our applications in a more maintainable way and helps keep things organized. There's also a detailed data management package to help model and manipulate data on the front end in a consistent way that mirrors the back end structures and lets us interface with the back end in a much more smooth and easily integrated way. There's also a really advanced grid component, which we'll talk about later on. We've got a few demos on that. That's the sort of flagship component in the framework because, as I said, these applications that are being built with it are really data intensive. And so displaying that huge amounts of data with details in a grid is really important. There's also a full canvas-based charting package built in, and there's also a lot of multiple themes that we can use to customize the look and feel of our applications. So these are the sort of compelling features of the framework, but let's take a little deeper look on why you might choose XJS. So obviously technology choices are directly impacted by business needs. So we'll talk about how these business needs fit in with the framework choice that you might make. So obviously everyone wants to be able to develop quickly. Being quick to market and being able to react to changing customer demands is critical to success, and you need to make technology decisions that will let you do that. So the biggest way to speed up development is to write as little code as possible. So we want to offload as much code as we can to someone else, in this case to the Sencha team that build the framework. So to start with, we have hundreds of UI components all ready to use. There's complex grids that we've mentioned, there's forms, trees, toolbars, pagination, all that stuff is built in, tested, and complete and ready to use. So we can forget about any of that stuff and focus on our application and our customers that we're building for. Because we all know you can sink days and weeks and months trying to create your own UI library or UI components, and so why bother when we can get that stuff built into the framework. It also has a ton of utility features built in, and things that you might need to load third-party libraries in to handle. So things like date manipulation, drag and drop, string manipulation, that sort of thing. But all these are all sort of small utilities, they quickly add up. And in terms of decision fatigue, because there's lots of options to choose from, and you have to figure out how they integrate with each other, and knowing what standard they're developed to, and that sort of thing. That adds a lot of overhead to your project, and you can sink a lot of time into it. And if with all that built into this framework, you can skip that step altogether. The components are also built to accessibility standards, so it's another thing you and your team don't have to worry about, because that's built into the framework, and you can comply to the accessibility standards straight off the bat. There's also support for localization and right to left text formatting. These are things that we've all been there, where they've been brought up months into development, and you realize you've got to try and retrofit them into the application. So that all that stuff is built in, and you can turn it on and off as you need. Also, the components that exist are really extendable, so we can, although if something doesn't quite fit your requirements, you can build upon it and adjust it as you need, and that will mean that you can stand on the shoulders of giants, if you like, and just tweak things as you need and make them perfect for your application. The last thing to mention is the mature tooling that we've got as part of the XJS sort of bundle. So there's things like Sencha Test, Sencha Architect. It lets you create UI tests, and Architect means you can build applications without actually coding at all. You can configure all your components in a GUI interface. So that's a really big help. And along with those, there's a whole host of other tools for developers and QA people as well. So enterprise applications, they have extremely complex business processes and workflows that have to be translated into code, and most importantly maintained after they've been built the first time. And you can also bet that these processes are going to be constantly changing. So this means that you've got complex data structures on the back end, and XJS has a really strong data package that lets you model these structures on the front end and keep that data manipulation as simple as possible and as close to the back end architecture as possible as well. Also, the MVC and MVVM architectures that are built into the framework help you write really testable code that lets you verify that these business requirements are correct. So that's really important for creating a solid application. And the framework's also quite opinionated in terms of how you structure your application. So following best practices is promoted naturally and gives you a much more maintainable application, and also one that can be, new people can come into your team and get started really quickly with. Obviously, the applications that these types of teams are building are generally business critical, so the reliability is paramount, because breakages and downtime cost a lot of money to the business. So when we've got a business critical application like these, we need a mature and stable tools that move forward with technology changes, but do so carefully with no regressions. So the fact that XJS is developed by a dedicated team and a company behind it, they can ensure that the delivery quality is high, and that we we can rely on the quality of the product and take that into our applications. And there's also really good support channels where you can report bugs or get help with queries or issues as you go. So that's another good reason for choosing the framework. And we also want these applications to build the test of time. So when you're building these large applications, they're being created over the course of months and years, and so they need to, that investment needs to be able to last. So XJS is built on web standards, so it's designed for longevity. It's polyfills in place where native implementations aren't available yet, and they're designed to use the native implementations when they can, so that we're sort of growing with the browser support as it comes. And there's also an open source version available, which means that the community contributions can extend the life of the product even further, and help us maintain the product into the future. So where does the XJS fit into the sort of larger landscape of JavaScript frameworks, of which there are many? So what are the open source alternatives? So we mentioned before, the big three that you might consider when you're selecting a front-end framework are React, Vue, and Angular. And these are the sort of three most popular choices at the moment, with a few others on the outskirts, growing in popularity. So these are all great choices when you're building a new reactive web application. But when you choose to develop an application with one of these, you're choosing it and a whole host of other additional third-party packages, both open source and closed source. And it's this need to introduce a huge number of dependencies that, in my eyes, is the biggest shortcoming with going down this route. So to sort of demonstrate how they can be compared, so when people try to compare JavaScript frameworks, they try to compare XJS with these three libraries, but it's not really an apples-to-apples comparison. So, for example, if you selected Vue as your open source application library, you then need to pick a UI framework, something like Bootstrap, and then you need to be able to handle data properly. So we might choose Vuex, and then we need to handle AJAX calls to the server. So we bring in Axios as that handling library, and then you might need to do some data manipulation. So you bring in Moment.js. This sort of continues to meet all the requirements in your application, and so now you've got dozens of packages that combined to become an apples-to-apples comparison with XJS, because it has all those things built in already, and so you don't have to do all that research on what library is better or has the things you need, and evaluate it and check it integrates properly and that sort of thing. So it's really the comparison is really one of the big three, and plus X number of other packages that build up the full solution that you need, and which XJS handles for us. So we're going to move a little bit more into the how to use the framework and the sort of characteristics of it. So the design philosophy of XJS is it's a JavaScript first approach. So instead of writing templates with HTML, we actually do everything with configuration objects, JavaScript configuration objects, and then making use of the components that exist in the framework. So the applications are made up of reusable classes, which are for business logic and functionality, and components, which is the UI part of the framework. So an XJS component can be thought of in the same way as an HTML element, a sort of building block for creating a complete UI in the browser, but we rarely actually write HTML when we build XJS applications. We're primarily just configuring the components that exist in the framework. So we create components, as we said, by using configuration objects. So in this example here, we call the x.create API and pass it a configuration object to tell it create a component with this specification. So you can the X type property here is you can sort of think of it as the HTML element name. So in this case, button, but we also have things like text fields, forms, grid, that sort of thing. And that's the type of component that you're creating. Then all the other properties become characteristics of the component itself. So there's lots of general ones, things like hidden, disabled, that sort of thing. But there's also component-specific ones. In this case, text, which is the text of the button, and handler is the function that is run when you click the button. And then on the right here, you can see that's what output to the browser. Generic blue button. So that's how we create components in the framework. Generally speaking, in our applications, we don't create components sort of directly. We try to encapsulate their configurations in our own classes. So we make use of this API called Ext.define, where we create our own component based on one of the library components, or in fact based on one of our existing custom components. So in this case, we're extending the button class and creating a new class called myButton, new component. We give it its own X type called myButton, and then we define the properties that it has, the text of the button and the handler. And then at the bottom here, you see we use the create API to create an instance of that button, and it will have that configuration built into it because of the definition that we've created above. And we can go one further and extend our own components to compose complex interfaces. So in this case, we can see we're creating another component called mySpecificButton, and we're extending the myButton class we created in the previous slide. We give it a new X type, and we can change the text because we can override the configurations that we already have. And then we can then create it in the exact same way using the new X type, and it will have the new text of OK, but it will also inherit the handler property and any others that we might create or specify from the base class. So that's how we sort of make use of the components in the library, and how we can compose interfaces based on extending the framework's components and building up our own as we go. So I wanted to move on to some demos now, just to demonstrate some of the the sort of interesting features of the framework, and how give you insight on how we might build up a more sort of fully featured example. So we're going to start with a grid example here. If you have managed to get hold of the slides, you can jump to the Fiddle address there. That Fiddle.sencha is a sort of playground for creating little examples and that sort of thing, a bit like JS Fiddle. So we're going to create this grid here and show you how easy it is to create a big fully featured grid with date formatting. We've got a sort of sparkline graph in there, and on the right here we've got nested columns as well. So let's jump into that example, and I'll show you how the code fits together. So this is Sencha Fiddle. We've got a code editor in the middle here, and we've got the output on the right. So our application starts with a call to Ext.application, as you can see here. And this is our entry point to the application, and what this is loaded on the page. And we will hit our launch function, and this will start our application instance and get us going. So in this case, you can see we're using Ext.create API, and we are creating an instance of the employee grid class, which we have defined, and we'll show you that in a second. And we're telling it to render to the document's body. Generally speaking, the sort of root component is rendered to the body, and everything else is added as a child component of that. So in this case, we've only got one, so we're just going to render it straight to the body. And we give it a height and a width and a margin just to see it spaced out a little bit. So we have a folder in here called view, and we've got an employee grid here. So as I said before, we're creating our custom component called employee grid using the Ext.define API. We're telling it to extend the grid panel component of the framework. So that's saying we're going to use the grid panel, and we're going to all these configuration options will feed into that panel and configure it correctly and draw it to the screen. So let's just get down to the columns. So A grid generally has a couple of required configurations. We need a set of columns to know what data to actually show in the grid, and we need a data source. So to start with, we'll just talk about columns. So we just give an array of JavaScript objects. We tell it what we want the header of the column to be. In this case, we've got forename, surname, and rating, date of birth, that sort of thing. And we tell it what property of the data source we want to show in that column. So in this case, we've got data index is equal to forename, and we have surname, and various others on the way down. So these first two are sort of simple columns, just text. They'll just output the data property as it is. But we can have more complicated columns as well. So this one is called a widget column, which means we can basically render another XJS framework component in the grid. So we might want a button, or we might want a text field, or a slider, or something like that. So in this case, we're outputting a little sparkline grid, chart, and we're hooking it into the data index of rating, which is an array of values. And so that will take that array of values and just draw a little graph inline in the grid, with only that configuration. And then further down, we have a date column, which handles dates properly and lets you format the dates correctly and that sort of thing. So we have a whole bunch of columns, but now we need a data source. So what we can see here is we've hooked in a view model. So we're using the MVVM architecture here. So we've tied this view model to the grid. So we're going to jump into the view model now. And again, we use the Ext.define API, and we set up the view model name, and we extend the Ext.app.viewModel class. We give it an alias, and that's the string that we saw in the grid. We referenced it by this. And we can set up a data store here that will pull data from a backend and make it available to any component that wants to use it. So we have a stores property, and we create an employees data store. So we can configure this in a few different ways. We have a fields config here. This means we can list out all the fields that the data source or the data coming from the server will have. By default, if you just leave this blank, it'll just pull in all the fields and just keep them as is. But we want to do a wee bit of date parsing to get these dates into a proper JavaScript date format. So we can specify these here, the name of the field that's coming in. We're telling it it's a date type and to handle it as such, and we give it a format. So this is the incoming format, so we can use that to parse the date, turn it into a real JavaScript date object. We tell the store to load automatically as soon as the this class is instantiated, so we get that data straight away. And then we define a proxy which tells us how to get the data in from X, somewhere outside to the data store. So in this case, we want to pull it in by Ajax, and we have a URL that just points to a JSON file, which we will show you in a second. And we tell it that we want to read it as JSON because it's a JSON file that we're pulling in. So with that in place, our data store will load when the grid gets instantiated, and it will populate the columns as we define them. So with that in place, we can click run, and it will give us this. So you see the little spinner there automatically shows when the data source is being loaded, and then we get our grid full of data, and we see we've got a little graph that shows up. Our dates are formatted correctly, and we've also got this nested column structure where we didn't actually show. So this is our nested structure. So if we've got grouped columns that we want to tie together, in this case we want to group absences together, we can just nest a columns array in here and just do the same thing as we did before. So this could have another graph, another UI component, or dates, whatever, and they will be nested like this in a nested structure. So we didn't actually talk about how we tied the data source to it. So we missed that bit. So we've hooked up the view model. So we've tied the view model to the grid, but now we need to tell the store to be attached to the grid. So we use this bind property, which lets us bind configurations of the grid to the view model that are dynamic values generally. So in this case, we want to hook up the store property with the employees store. So we use this curly brackets notation and the name of the store, and that will populate the store config with the view model's store, and I'll tie them both together. So at the moment we're just displaying, so we've got a count here of 500 employees. So let's bump up the amount of data coming back, just so we can demonstrate the sort of speed of the grid. So this has got 500 or so. It'll just multiply it by 100. So we can see the grid takes a little bit longer to load as that comes over the wire. While that's loading, we'll just quick talk about this. So obviously, so we can nest components. Components can be containers for other components. So in this case, a grid can have a docked items collection, which will be items that are either stuck to the bottom or the top or the left or the right of the panel. So in this case, we're just having a simple component, which you can kind of equate to being a div in real HTML land, and we can just provide an HTML property that will be populated in there. And again, we can use this bind property and access parts of the view model that data points in the view model that exist. So this template just has employee count, and then this curly brackets will be parsed out as accessing the employees store, and it will access the count property of it, and that will give us the count of our store currently. So this is showing that we've got 50,000 records in this store. 50,000 records tied to the grid, and you can see, I'm just scrolling it. It's really smooth because it does some clever buffered rendering in the background. And equally, this could be hooked up to a page data source as well, and that that smooth scrolling will maintain as new records are loaded in from the back end. So that just shows you how well the grid can cope with high numbers of records. That's 50,000. You could maybe load in even more, and it would still be nice and smooth. So that's the simple grid grid implementation. There's very little code needed to get something quite quite complex on screen. A lot of other things that we didn't even talk about. You can click column headers to sort the data all built in. We can turn off columns. We can add them back in. It even has the nested structure there already. So that's a lot of powerful things without really doing any work. We've configured what columns we want. We've tied a data store to it, and away we go. So our next example I wanted to show you was how we can extend this further and make it a grouped grid. So we'll just move on to this fiddle, which is exactly the same apart from the new grouping pieces. So to group a grid, all we need to do is we can make use of this features config of a group. So grids have this concept of features where there are little extra bits of functionality you can optionally pull in, and the grid will use them and add that functionality to the grid. So in this case, we want a grouping summary, which is effectively this little summary row that appears above each group, and we can have a template which we want to just show the name of the group, and then so that will let the grid support grouping, but we also need to tell the data source to group itself. So we go back to our view model and our employees store, and we tell it to group on the department field, and that will group all the employee records by the department that they're in. And that's all we need to do. So we can run that, and we will immediately get data grouped by the department. So we can now collapse all these different groups and see them all these records grouped by the department. And equally, this will work fine with, this is 500 records. You could have 50,000. It would group them just the same, and render them nicely and smoothly as you scroll. So that's how, if we were doing this with well, if we're doing this with traditional HTML, JavaScript, this would, it'd be a lot of work to get that working. But with XJS, we can just add, what was that, 2 properties, configuration properties, and it gets the it done with little to no effort at all. And this could be a dynamic field, so we could change that on the fly. If you wanted to have buttons up here to group by department or join date or status or whatever, we could have that data updating dynamically. And we'll talk a bit more about dynamic data in a second. So the final thing on grids, I wanted to talk about editing. So this is a third fiddle, which is exactly the same starting point. We have our grouping in place. So we might want to be able to edit the data on the grid. So there's 2 ways we could do about it. We could make a form and put a form on screen and have to click on a record, take it to a form, and then type in the edits and then save whatever. But our grid can have inline editing built in, so that's what we're going to set up just now. So if we go back to our grid component, what we need to do is add this a set of plugins. So we can add plugins to this as well. They're similar to features. They're slightly different, but they're very similar. So we have this row editing plugin, and that lets us, when we click on a row, we can activate the editing mode, and it will give us an interface to edit that row inline in the grid. So we set up, we add a plugins config with an array of plugin configs. In this case, we just give it the type, which is a row editing type. And then all we need to do is, for each column that we want to be editable, we need to add an editor to it. So in this case, we want the forename to be editable just with a simple text field. But we can configure that as we would a normal text field anywhere else in the application. So we could set up the maximum characters, we could set up some validation, we could make sure it doesn't let us have a blank, allow a blank field. So any configuration for an editable field can be put in here. So we've got text fields for the first forename and surname, and we're going to have a date field for the date of birth and the join date. So this, as I said, this could be any field that we have in the framework. So there's number fields, there's date fields, there's file fields, there's combo boxes, there's sliders, all that sort of stuff. We have built in, and we can put in these grids. So with that in place, all we need to do is run the code, and now we can double click on a row, and we'll get this little row interface here, where it shows the configured field for each of the columns. So forename surname had a text field, the 2 date fields had a date field, the rest were all read only, so they don't have any fields. And we can just type in the field, we can open up the editor.
Hi, Stuart. Welcome back.
Hi, folks. Sorry about that. A power cut randomly, and obviously that killed internet and everything. But it seems to be back on now. So really sorry about that. Typical happening just when you're doing a presentation. So I'll try and pick up where we left off. Is that all right?
Yeah, that's perfect, and that's of course this isn't your fault, so that happens. Murphy's Law, right?
Yeah, exactly. So I think we talked about row editing. So let's just move on. So we're running short on time. Just tell me when you want me to stop for, and I'll we can move on to questions. So the next thing I wanted to demo was some data binding things. So obviously, data binding is really important in building applications. So I wanted to show you how XJS handles binding data to components. So we already saw that we can bind data sources with data stores with grids, to make full grids setups, but we want to do a bit more sort of smaller level things where just sort of small bits of data. So this example here, which I'm going to bump up size wise, you can see. So we have a new view model, this test view model, This is all done in line rather than separate files, which we generally wouldn't do in a big application, but we can do it in our demos here. And we define a data property object, which can have any number of little small data fields that we want to bind to things. So that might be, in this case, filter string. It might be a record name or checkbox Boolean value, that sort of thing. So we've got one called filter, and we're going to create a form panel. So in this case, we're just using x.create directly. We're using the form panel, rendering it to the body with a height and width, and we're tying our view model to it. In this case, we've got our items array, which is how we define nested items within a container. So in this case, a form can have any number of fields or components. So in this case, we're defining a text field. We've got a label, and we're binding its value to the filter property that we created in the view model. So these are bind config, and any config inside this bind value, and this bind object will be bound to the view model variable that we create. So we've got this in filter. And the next one we've got is a component, simple component that has an HTML binding, and it will display that filter value. So these two values, these two values are the same. So when we type in here, we type hello, we will see the value comes out of the text field and goes into the view model through this binding, and then it will come out again and will be displayed in the component through here. So that will so that shows how we can bind data values to components. And we've got a reset button here, which will just to reset things, we'll look up the view model, so we'll find an instance of the view model that's attached to this set of components, and we can manually set the filter to empty, and that will trigger an update to filter through the components that are tied to that component. So in this case, the text field and the component, and it will it'll clear those values. So that's how easy it is to get data tied to components. Just simple fields and display values. So to take that a bit further, refresh this one. We can also have simple values like we showed, but we can also have formulas which are sort of will be bound to other data properties as part of the view model. So in this case, we're going to create a formula called show filter, and we only want to show the little summary that we had in the previous example. We want to show this part if the filter value is length is greater than 3. So we have a formulas option, and we have a new property. It can be used exactly the same way as the data property. It's more read-only because it's calculated from other values. So the function takes one parameter, which is a get, which we can use to get a data property out of the view model. So in this case, we get the filter, we check the length, and then we return, if it's greater than 3 or equal to 3, we return true, otherwise we return false. And then in the same way as we've done before, we combine the hidden property with this show filter formula, and we can even use the exclamation mark to negate the value, so that if show filter is true, then hidden is false. We'll evaluate to false. So now if we type in here, we don't see the value until we hit the third character, and then it shows up. And then as we go down, we get to 2 characters, and then it hides, because that formula is constantly reevaluating, and when the value changes, it'll cascade down the component tree, and anywhere that uses it will get reevaluated, and any configs will get switched to the new value. So in this case, the hidden property will be set to false or true, depending on what the bound value is. So that's how we use formulas. So we've got a few more minutes to go. I'll skip over that one, and we'll go straight to the to how we tie functionality with view controller. So that's quite an important one. So just let this load, and then hopefully we'll still have some time left over for questions, if anyone's got any. Just let this load.
Yeah, we have a couple of questions here, but we can take them at the end if you want.
Yeah, okay, cool. Well, look, I'll just run through this one quickly and then we'll have some time for questions. So this is an extension of our existing models. We've got our test view model. Now we've got our employee store back. But now we've got an extra property called filters as part of the store. So you see this as employee stores. We've got fields and we've got our proxy. Now we can bind some filters directly to the store. So we're going to create a filter on the forename property, and we're going to tie it to the filter data value that we have in the view model at the top here on line 18. So anytime that filter value changes, the store will do a filter and will output the results. So if I type in here, type in David, then it will automatically filter the results based on that. So now all we're seeing is Dave's and David's in our grid. So that's tying all these data values directly to store filters. So that's a really neat feature. And finally, we're going to talk about the view controller. So we've created a view controller here, which extends this class here, x.app.viewController. And we've got this function here called onItemClick, which is going to be triggered when we click on a row in the data in the grid. And we're just going to alert a message with some of the details of the grid that was, the row that was clicked and the filter that's on there already. So we've created this function called onItemClick. And then on the grid down here, we have a listeners config in which we can use to attach events to components, because all these components have lots of events firing all the time, like click events, selection change events, item click events like we're using here. So that all these events can be tied to a handler here. So we say the item click event, we want to use it, we want to tie it to the onItemClick method name. We define it as a string, and it will automatically look in the view controller for a method of that name and hook them together. So now if we click in the grid, we can see item clicked, our filter was DAV, and the record we clicked was the forename and surname was David White. So that's how we start tying logic up to our components and start adding interaction and how we might flow through an application as we click on things. So if we clicked on this row, we might take us to a details screen that pops up with details of the employee, all this information attached to them. So that's how we might do that. So that's how we tie some interaction to the components. I'll stop there. Thank you very much, everyone, for listening. Sorry about the interruption in the middle. Hopefully it didn't cause too many inconvenience. If there's some questions, I think Finley said there's a couple. I'm happy to answer them now. And as you said, if there's any other questions that come up later on, feel free to drop me an email. I'll get that up on screen in a second.
Yeah, perfect. So let's take a couple of the questions. Let's see how many we can go through here. So I have one here that's what's the difference between Ext JS and jQuery?
So Ext JS is a full application framework. jQuery is much more of a sort of a utility library for DOM manipulation and sort of smaller interactions with the user. Excuse me. So you might use jQuery to target some elements on a screen and change their values, maybe change the colors, add some handlers to them. And you might couple with that something like jQuery UI, which would bring in some more advanced UI components. But XJS is more of an application framework, so it gives you all the structure to sort of fully architected applications that are going to grow bigger rather than being where jQuery, where it's more of a sort of you sprinkle it on top of a regular HTML page that might be server-side rendered. So XJS would be more for creating single-page applications, whereas jQuery is a bit more like sprinkling some interactive functionality onto a server-side rendered HTML page. So they're quite different. And generally, XJS has most of the functionality that jQuery has as a DOM manipulator type library built in. So you generally don't need both running side by side, but you can do if you really wanted to. If you wanted to take some of that, use some of that functionality from jQuery in there.
Okay, yeah, good. So another one here is, what's the latest version and what's the biggest new feature?
So the latest version is 7.5. So there's, I don't know if there's any sort of headline features that came out in version 7, or sort of improvements and fixes and that sort of thing. One of the big things that is definitely being improving and has been built upon in the latest version is the open tooling, which lets us use Webpack and integrate much more closely with NPM ecosystem, so we can use those packages much more easily in our XJS applications. So the new versions are constantly improving, adding new themes and often a few new UI widgets as well, if when they're needed.
Okay, yeah, good. Another one here is regarding what are the most popular UI components that are used with XJS?
So the most popular, I think, is the grid, which is why I kind of did a few demos on that. As I said before, the applications that tend to use XJS are very data intensive applications, and so there's lots of tables of data needing to be shown and manipulated and on screen. So the grid is really a performant way of doing that. So a lot of people make the decision based on the fact that it's got this really good grid, and that's one of the big things that people are drawn to, because they want a performant grid when they're dealing with thousands and thousands of records all at once. So that's the sort of headline component, if you like. But obviously it's got a component for pretty much every sort of UI case that you would need. And if there isn't one, there's often user extensions out there that fill those gaps. And it's quite easy to build upon something that gets you partly there and create your own component on top of it.
So with that, thanks a lot, Stuart. We had a bit of a technical problem, but I don't think it mattered too much, and you handled it very well. So thanks for a great presentation.
Great, thanks a lot, everyone. Yeah, apologies for the interruption. And yeah, any questions, just give me a shout.